Okay, moving on to 13. I just realized that this is a video. You guys can pause it and stuff, and so I should just go really fast, right? Um, so let me just discuss my work here really quick. A definite integral of this represents, okay, so I'm assuming you guys read the question. They're assuming that just because this A is below the B, it doesn't mean A has to be smaller, right? And I showed that using something like this. Remember the rules for integration? You can actually just switch these guys by adding a negative. So there's no indication that A has to be smaller than B. There's no rule that says that, okay? So if that's the case, I mean, like, I could say none of these have to be true. A is smaller than B or A is bigger than B, I don't know, right? And they're also saying that, hey, since the region is bounded by y equals f of x, the x-axis, blah, 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 I drew a proposed solution of the graph right here. You guys can examine it. Obviously, I have parts of the f of x below the 0 or below the x-axis, and I have parts of the f of x above 0 or above the x-axis. Obviously, I intentionally put b less than a. So, and by doing that, I'm saying that, hey, you don't have to have any of these conditions just because you have a definite integral like this. So this would be none of the above. Okay. Number 14, I did my work here. Suppose the f of x is a twice differentiable function. If you guys can read me, I can, oops, we delete all that. Okay, so twice differentiable function, blah, blah, blah. I'm assuming you guys read it. Okay, which of the following statements must be true? This is the only thing I need to consider this problem. F prime of c is equal to 0. There is a horizontal slope there. And the value of c is between a and b, okay? That's it. It's twice differentiable, which means you can take the derivative twice. It's continuous, no holes, and all that good stuff. So I drew a proposed graph of what's going on in this problem. And you notice I have, okay, C is between A and B. Great. I have a horizontal tangent at C. There's a slope of 0 right here at C. And I also intentionally put f of A lower than f of B because I can, right? Now they're asking for what must be true. So I'm proposing a solution that doesn't have to be true, right? As long as I'm satisfying all the conditions of what they told me in the original problem. So according to my drawing here, well, f of A does not equal to f of B, okay? F of B is higher than f of A. There's a slight lag here. And so I say number 1 doesn't have to be true, right? Number 2, f has a relative extrema at x equals c. The way I drew the graph, this curve goes like this. There's definitely an horizontal tangent at c, but it's not a relative maximum or a minimum. It doesn't have to be, according to my drawing. So 2 doesn't have to be true. And then number 3, f has a point of inflection x equals c. Now I purposely kind of drew this at c longer than just one point. And my point is, it doesn't change concavity exactly at C. It stays flat for a good amount of space from like here all the way to here, which means it doesn't have to have a point of inflection at C. Okay, there's no indication that it has to change concavity exactly at point C. So by that, number 3 is wrong. So A would be my correct choice. Okay. Moving on to number 15, a skydiver negative velocity. I'm assuming you guys can read it. Again, like I said, you can always pause this video, which is kind of cool. Okay, if my velocity decreases quickly and then levels off due to the air resistance, that graph, right, it looks like this. A, you see how the velocity is decreasing quickly and it starts to level off. That's great. So A would be my velocity graph, or everything that this problem is talking about before the question. The question is asking for which graph approximates the acceleration, right? And if you guys forgot, acceleration is the derivative of velocity, which means acceleration is the slope of velocity. And if I already told you that this is my velocity graph, A, well, I need an acceleration graph that represents a negative slope everywhere, which means I have to have my entire graph underneath the x-axis. And my slope looks like it's starting to get less negative, right? And it starts leveling off that 0. So the only graph that represents that is D. This graph is going up, which means it's getting less negative. These are all negative values here, but it's getting less negative and it's starting to level off at 0. So D is my acceleration graph. Okay, moving on to number 20 for what values of K, blah, blah, blah. Okay, so if you have a relative maxima at x equals 4, which means I gotta take the derivative and critical numbers, and I'm gonna get a value of x equals 4. Okay, great. So here I did my work here for my derivative. I simplified all that good stuff. Feel free to pause the video and stare at that for a little bit if you need to. And then at the very end here, I got here set equal to 0. Okay, so I solved for k equals to negative 4x, but they told me x equals 4 in the original problem, which means x must equal to negative 16. So my answer choice is B. And that's it.